A vehicle travels at 90 kilometers, starting from 0 kilometer per hour. Travels 90 kilometers, and they didn't put if it's per hour. I believe it should be per hour. So that should be vehicle starting from 0 kilometer. Okay, that means let's call that V. Let's say V is equals to 90 kilometers per hour. And notice that U is equals to 0 and at time 0, so there's nothing there for us. So it now accelerates. For 20 kilometers per hour. So acceleration is 20 kilometers per hour square. Then they're asking us what is the velocity after 2 hours, at t equals to 2 hours, after t equals to 2 hours. So that means that automatically at t equals to 2 hours, this becomes our initial velocity. The vehicle travels at 90 kilometers per hour, starting from 0 kilometers per hour at t equals to 0. So at t equals to 0, it's traveling with this. So after 2 hours, this should be the initial velocity. So it's now the sentence as saying V, our V, this should be U equals to 90 kilometers per hour in 2 hours, or after 2 hours. So you remember that acceleration is equals to V minus U. V minus U all over T. So but right here we have that acceleration is 20 and V is unknown. The final velocity is unknown. Minus 90 all over 2 hours now. So I'm using everything kilometer and the hour like that. At the end of the day, I'll convert. So this will now be the sentence as saying crossover. So we have 40 equals to V minus 90. That is crossover 2 coming 20 times 2. So 40 plus 90 is equals to V. So if you calculate and put your 130, so V is equals to 130 kilometers per hour. And this is the sentence saying V is equals to 130,000 all over 3,600. So let's check it. 130,000 divided by 3,600. This should be 36.1111. So V is approximately 36.1 meter per second. So this is what V is. So let's solve for question 9. Question 9, they said derive the equations of motion. Okay, we've already done that. Check our first video. So question 10. Just type kinematics on the channel. If a car moving at a velocity of 20 meters per second is brought to rest in 10 seconds by the application of brakes, what is the acceleration? If a car moving at a velocity is brought to rest, so V, final velocity, whenever you hear brought to rest, know that they're talking about final velocity. In 10 seconds, the application of brake is acceleration. So question 10. 9 is there on the channel. So 10, the car moving with velocity. So whatever is given becomes the initial 20 meter per second. Brought to rest, v equals to 0. Then t in 10 seconds. What is the acceleration? Acceleration equals to v minus u. V minus u all over t. So this is the same thing as saying v minus 20 all over 10. A is equals to minus 20 over 10. Okay. A is equals to minus 2 meter per second. And notice it's minus because it's deceleration, it's brought to rest, retardation. So that will be that. Let's move to question 11. I said a proton with an initial velocity of 10 meter per second, 10 raised to power 5 meter per second, enters an accelerating region and emerges with a final velocity of 10 times 8 meter per second. How long is the accelerating region? Simple question. Question 11. The acceleration they are asking us, A equals to V minus U over T. So this is the sentence saying, then the first acceleration is, the final, is 5 times 10 raised to power 8 minus 10 raised to power 5 all over 10. So this should be the sentence saying, this is the sentence saying, should I say, let's bring out the, okay, let's just do it together to avoid confusion. Let's say 5 times 10 raised to power 8. This is 500 million. Yes, 500 million. Then minus, okay, minus, minus 10 raised to 5 is 100,000 all over 10. So let's do 500 million minus 100,000. So we get 499 then 900,000 all over 10. So this is the sentence and this go here. So you know that this is the sentence and 499 90,000. So this is the final answer, and it's in meter per second square. Okay. Question 12 says an electron enters a region with a speed of 5 times 10 raised to the power 6 meter per second and is slowed down at the rate of 1.25 times 10 raised to the power 14 meter per second square. How far does the electron travel? So it entered with a speed of and is slowed down at the rate of. Now after that they ask what is the total time taken. So let's just write. So question 12. Question 12. So an electron enters a region with a speed of u is equals to 5 times 10 raised to the power 6 meter per second, and is slowed down at a rate a is equals to 1.25 times 10 raised to the power 14 meter per second square. And they're asking how far s does the electron travel. And they're asking what is the total time taken. So, but we know that from this question, we are given speed, we are given acceleration, we are not given time. Okay, let's just think. V is equals to S over T, shall we? And then A is equals to V over T, shall we? So let's apply this one. So here I have 1.25 times 10 raised to the power 14 is equals to 5 times 10 raised to the power 6 all over T. So this is the same thing as saying T is equals to 5 times 10 raised to the power 6 all over 1.25 times 10 raised to the power 14. So T is equals to, let's say I do 5 over 1.25 times 10 raised to the power 6 minus 14. T is equals to, let's do it, 5 divided by 1.25 equals to 4 times 10 raised to the power minus 8. This is my T in seconds. So then I now, to find the displacement, that is, let's say how far, displacement is always S. I'll just do, make this so all over 1. So S is equals to VT. So S will be equals to 5 times 10 raised to the power 6 times 4 times 10 raised to the power minus 8. S will be equals to 5 times 4 times 10 raised to the power 6 minus 8. So this is equals to 20 times 10 raised to the power minus 2. This is my final answer. So this is the displacement, the how far, S, and this is my time. So I simply got it by first doing A equals to V over T, then applying this one, very important. So let's go to question 13. Okay, I think before question 13, okay, let's just follow it. Okay, before question 13, let's look at question, because question 13 looks like graph. So let's look at question 14 and still come back to question 13. A body moving in a straight line with an acceleration of 12 meters per second has a velocity of 80 meters per second after 5 seconds. Find the initial velocity of the body and the distance covered in the 9th second. Another big one. So let's solve. To find question 14, to solve question 14, I will bring out everything given in that question. Question 14. I said a body moving in a straight line with an acceleration A equals to 12 meters per second square has a velocity V which is equals to 80 meters per second. 80 meter per second after 5 seconds. Find the initial velocity, which is u, of the body, and the distance covered, that is, or displacement. I told you they are the same thing. After the 9th round, after the 9th second. Okay, this is everything we are giving. First, we can employ the equations of motion. Since we don't have displacement, so we don't have initial velocity too, so we can just say v equals to u plus at. Understand? So that we can now say 8 is equals to u plus 12 times 5. That is for the first phase. So this is going to be the same thing as saying 12 times 5, 60. 60 plus u equals to 80. So u should be equals to 80 minus 60. U is equals to 20 meter per second. Very simple. We've gotten our initial velocity. Now they asked us for displacement in the 9th round, in the 9th second. Displacement in the 9th second. I want you to remember that they said displacement in the 9th second. Displacement is given by, if you use the equation of motion, is given by ut plus half at square. So if they ask us for displacement in the 9th second, anytime you hear displacement, is always x2 minus x1. That is final position, second position minus first position, or third position minus second position. Which means if they ask us for displacement in the 9th second, it should be 9th displacement minus the 8th displacement. So we have we have to find the 8th displacement and the 9th displacement. So for that reason, displacement in the 8th position, the 8th displacement, that is in the 8th second, should be u20 into remember we don't know the time. Okay, in the 8th second, yes, the 9th one will be in the 9th second. 8 plus half a is 12. Our acceleration is 12. Then our t is 8. So all square. So this should give me 20 into 8, 160, plus half 8 square 12, then 8 square is 64. Okay, now 12 into 64, 12 times 64 is 768, then half plus 160. So by the time you do 768 divided by 2, you have 384 plus 160. So 384 plus 160 should give you 544 meter. That is S8. Then that means we've gotten S8. Let's get S9. So displacement in the 9th second will be 20 into 9, then plus 1 over 2, 12 into 9 square. 20 times 9, 180, plus